Good day, students. Welcome to part 4 of the Algebra and Functions review for the Cahsee. In this installment, we're going to be going over problems 101 to 108. Remember, you can access the collection of Cahsee review videos on notgoodserved.com. All right, let's take a look at question number 101. We're asked to solve for n in the inequality 2n plus 3 is less than 17. All right, so anytime you're solving inequalities, it's as though you're solving an equality. This is a linear inequality in this case. The only difference is anytime you divide or multiply by a negative, the inequality switches its orientation. So if it's less than, it changes to greater than. If it's greater than, it changes to less than. In this problem, this is a two-step procedure problem to isolate n or solve for n. We're going to get rid of the 3 and then the 2. All right? There isn't any division of a negative number in this process. So this inequality symbol is not going to be inverted. Okay? So let's go ahead and solve it. We'll start from by getting rid of the 3. So you subtract 3 from both sides. And then these two 3's add up to 0. So we can cancel that out. And we're left with 2n. Now 17 minus 3 is 14. Now to get n isolated, the relationship between n and 2 is multiplicative, okay? So to undo multiplication, you have to do the opposite, which is divide. So we're going to divide both sides by 2, positive 2. So we're dividing by positive, so the inequality sign stays intact, okay? There's not a reflection on the number line. So n is less than 14 divided by 2 is 7. So as we can clearly see, our answer is option letter D for number 101. All right, let's take a look at question 102. It reads, the owner of an apple orchard ships apple boxes in that weigh 2 kilograms when empty. The average apple weighs 0.2 kilogram and the total weight of a box filled with apples is 12 kilograms. How many apples are packed in each box? So it looks like we are to solve for the number of apples that are packed in each box, okay? So whenever you're solving for an equation, you want to quickly assign a variable to what you're looking for. Okay, so we can say let x be the number of apples. Okay, number of apples in each box. All right, so x is what we're going to be looking for. So we're told here that the empty box is 2 kilograms. So let's say we have a box that's empty, like this. So this box has absolutely nothing in it. I'm going to call this box E because it's empty. So the box when empty is 2 kilograms, right? And it says the average apple weighs 0.25 kilogram, and the total weight of a box filled with apples. So how many apples are in a box? That's a question. How many apples are there in the box? We're not told about how many apples there are. So what did we decide to do? We decided to call the number of apples x. Okay? So if x is the number of apples and each one weighs 0.25 kilograms, what is the total weight? The total weight is going to be the unit weight per apple times the total number of apples. Okay? So for example, if you have one apple, it's going to be 0.25. If you have 2 apples, it's going to be 0.25 times 2, which is 0.5. So you always multiply the number of apples by the unit weights to get a total weight. Okay? So how many apples do we have in the box? We call it x. And to get a total weight of x number of apples, we're going to multiply it by the unit weight of each apple, which is 0.25. Okay? And that gives us a total of, we have a box that's filled with apples. Okay, so when this box is filled with apples, what is the total weight of the box filled with apples? The total weight of the box filled with apples is 12 kilograms. Okay, so this plus this gives us 12. All right, so to solve this, we're going to end up with an algebraic equation. We'll have 2 plus 0.25x equals 12. All right, so this is the resulting algebraic equation. All right, so to solve this equation, it would be nice if we didn't have a decimal, okay? So I want to get rid of this decimal. So we're going to ask ourselves, how many digits are there behind the decimal? Behind the decimal, we have two digits, so we're going to multiply it by 100. Two zeros for two digits. So what we're going to do is multiply this entire equation by 100. So what that does is it causes the decimal point to move two places back. So for 0.25, it's going to move back two places. For 12, it's going to move back two places, and for 2, it's going to move back two places. So if you move it back two places for 2, you're going to end up with 200. Okay, 200 plus 0.25 becomes 25x, and then 12 times 100 becomes 1200. All right, so to solve this equation, for x, what you're going to do is you're going to subtract 200 from both sides, and then divide by 25. All right, so let me continue my work over here. Get down here. So we'll have, let's write it 200 plus 25x equals 1200. So I'll subtract 200 from both sides. Remember, we're trying to isolate x, all right? So subtract 200 from both sides, we'll have 25x equals 1000. And then to finish yourself, divide both sides by 25. Divide by 25. And then x is what you get when you divide 1000 by 25. Let's do that real quick. 25 divided by 1000. Remember, the top dog goes in the doghouse, goes down into the division symbol, and the denominator goes outside. 25 goes into 100 four times. 4 times 25 is 100. We know that. So just move this 0 upstairs. So 40 is your answer. Okay. So there are 40 apples in the box in order for it to weigh 12 kilograms. So our answer is option letter B. All right, let's shift our attention to number 103. It says Brad bought a $6 binder and several packs of paper that cost 60 cents each. If his total was $13.20, how many packs of paper did Brad buy? So what do we do first here whenever you're solving a word problem of this nature? The first thing you want to do is you want to assign a variable to what you're looking for. So it asks for how many packs of paper. So we're going to say let x equals the number of packs of paper. Okay, number of packs of paper that Brad bought. All right. So we know that he bought a binder. So let's say this is the binder right here, a binder, and then he bought a whole bunch of papers. Let's make the papers look like this. So the question is, how many packs of paper did he buy? Well, we don't know. Okay. So, but we know that the total cost was the total cost of both of them together was $13.20. Okay, so let's call this binder and paper. So let's put this a box of, you have a paper together, you have your binder and your papers. Okay, just draw it as best as I can, everything together. So the binder, just one binder is $6. Okay, I have to put a dollar sign there. So the one binder is $6, but you bought a lot of paper, right? Several paper packs. Each paper pack costs 6 cents. How many? I mean, cost 60 cents, not 6 cents. How many paper packs did he buy? Well, that's what we're looking for. But since each one costs 6 cents, the total price for the paper packs will be the unit price, which is 60 cents, times the quantity, right? So the quantity is X, and each one is 60 cents. So we're going to multiply the quantity by the unit price, which is 0.6. Okay? So this is the price of the paper packs, and together everything costs $13.20. All right? So let's go back to question number 102 for a second. When we were looking for X number of apples, how did we find the total weight of this entire group? What we did is we multiplied the unit weight, which is 0.25, times the number of apples, which was X, which we didn't know. That's exactly what we're doing here. We're multiplying the unit price which is which is 60 cents, times the number of paper packs, which we do not know, which is X. So this product will tell you the total price of the paper packs that he bought. Okay? Alright, so let's generate an algebraic equation that we can solve. So this becomes 6 plus 6, x times 0.6 is 0.6x equals 1320. Now I like to get rid of the decimals from this problem. You notice that the highest number of decimals behind any of these numbers is 2. So this has 2 decimals, this has 1. So to get rid of 2 decimal places, I need to multiply the entire equation by 100. A 0 is a 0 for each decimal place. So this 0 is for the first move, and then the 0 for the second move. Or theoretically, we can just write this as 13.2. We can drop this 0 from the case. Okay, let's just do that. So we can, if I wanted to call this 13.2 like this, let's say I wanted to do that instead. I could do it the other way, but it's not necessary. Let's say I call it 13.2. Now, what's the maximum number of decimal point numbers I have behind the decimal point for every term here? The maximum number is 1 because this has one that has 1. So in this case, I can just multiply by 10. Okay? So what does this 10 do? It causes each decimal point to move one place to the back. This one goes one place backwards. This goes one place to the back. And this one goes one place to the back. Alright? So 6 becomes 60. If there isn't any number behind it, you put a decimal point and you just add a 0 when it moves behind the decimal point. 0.6 becomes 6x. And then 13.2 becomes 132. So this whole expression on the left is equal to 132. Okay? So this is the resulting algebraic equation. How do we solve this? We'll subtract 60 from both sides and then divide by 6. Alright, so let's go ahead and solve it. Subtract 60 from both sides. And that leaves you with 6x equals 72. And then to isolate x, you get rid of this 6 by dividing both sides by 6. And then your final answer is going to be x equals 12. So 12 is the total number of packs of paper that Brad bought. So the answer is option C. Alright, let's shift our attention to question 104. It says, where did it go? Alright, there you are. Okay, so it says a piece of pipe is 54 inches in length. A piece of pipe of 54 inches in length is cut into 2 pieces as shown in the diagram below. So this is the entire pipe, 54 inches. A portion is 26 and 2x is left. So the question is, what is the value of x? So we know that the total length is made up of a sum of these two lengths. So let's set up an algebraic equation, okay? So the sum of the two lengths, 2x, which is the left piece, plus the other piece, which is 26. If you add this length and this length, you get the total length, right? So this 2x plus 26 is equal to 54. If I solve this resulting equation for x, that will be the answer that we're looking for, okay? So how do we do that? Get rid of 26 first by subtraction, and then these 2 by division. So let's subtract 26 from both sides. Subtract 26, subtract 26. And then we have 2x equals 28. And then to finish this off, we'll divide both sides by 2. Divide by 2, divide by 2. And then we have x equals 14. So that's the value of x. So answer to number 104 is option letter B. Alright, let's take a look at question number 105. So for question 105, we're going to solve this using proportions, okay? So let's read the question first and then see if we can figure it out. Alright, so it says, Stephanie is reading a 456-page book. During the past 7 days, she read 168 pages. If she continues reading at the same rate, how many more days will it take her to complete the book? So we can use proportions here because we're notified that she reads at the same rate. Okay? So that rate is preserved. Okay, so what I'm going to do is I'm going to set up a ratio. So you have to be consistent with your numerators and denominators, okay? So I'm going to put page on top, page, and then time, and then days on the bottom, okay? All right, so for the first ratio, we're told that in 7 days she was able to cover 168 pages. So we're going to have 168 over 7. Okay? Now, what's the next ratio? It says, how many more days will it take her to complete the book? So how many days do we want to find now? We have, that's what we don't know. So let's define that since that's what we're looking for. So let x be number of days left, number of days left. Alright, so I'm going to call this x downstairs since the denominator is for days and the numerator is pages. Okay, so x is the number of days left. Now, how many pages does she have left to read? 456? Absolutely not. She has already read 168 out of 456. So how many left does she have to read? So you subtract, right? So what we'll do is we'll take the total number of pages, 456, and subtract the number of pages she has already read. Okay? Now, all right, so if we subtract 168 from 456, let's see, 6 minus 8. We can't take away 8 from 6, so we borrow 1 from 5. Make this 16. This becomes 4. 16 minus 8 is 8. And then 4, you can't take away 6 from 4, so you get to borrow 1 from 4. That makes this 3. 14, take away 6, you have 8. 3, take away 1, you have 2. So we have 288 pages left. So how long is she going to, is it going to take Stephanie to read 288 pages if she reads 7 pages, if she reads 168 pages in 7 days? All right, so we're going to solve this equation right here. Now to do this, we're simply going to cross multiply. If you cross multiply, the denominator goes to the top, both denominators goes to the top, okay? So we're going to have 168x equals 288 times 7. Okay? You can multiply it out, but it's not necessary because 7 might go into 168 nicely, like we see all the answers here look pretty good. Alright, so let's go ahead and finish it up. So we have 168x equals 288 times 7. Now, how do we solve this equation? To solve that, we're going to divide both sides by 168. So divide this by 168, and then divide that by 168. Okay? So we're going to have x equals 288 times 7 divided by 168. All right, you can multiply it out if you want, but it's fine. It's not necessary. So the question is, does 7 go into 168? Let's see, 7 goes into 16 twice, carry 2, and then in 28 4 times, so 7 does go. So 7 goes here 1. Let me use a different color. 7 goes into itself once, and then 7 goes into 16 2 times, which is 14. Remainder 2 and 28, it goes into 28 4 times. All right, so we have 288 over 24. Now let's see. Let's divide by 4 first. Okay, I know 4 goes in at 24 because 4 times 6 is 24. And if you look at 288, the last two numbers, 88 is divisible by 4, so the whole number is divisible by 4. Okay, so let's divide it by 4. 4 goes into 24 6 times. And then 4 goes into 288. 4 goes into 28 7 times. I'm sorry, yeah, 7 times because 4 times 7 is 28. And then 4 goes into 8 2 times. So we have 72 divided by 6. So what is 72 divided by 6? We know that that's 12, right? So 6 goes into itself once, and 6 goes into 72 12 times. So we can clearly see that the answer is option letter A. Okay? All right, let's move on to the next problem. Question number 106. It says Robert's toy car travels 40 centimeters per second at high speed and then 15 centimeters per second at low speed. If the car travels 15 seconds at high speed and then 30 seconds at low speed, what distance will the car have traveled? So anytime you see distance, rate, and time formulas, you want to you want to use the formula, the dirt formula. Okay, the dirt formula tells us that distance is equal to rate times time. The problem is asking us for the total distance that the car is going to travel. Okay, so we're going to break this formula into two cases. We're going to deal with the high speed and then the low speed. Okay, so for high speed, I'm going to call that as high speed. For high speed, we're going to use the rate at, so the distance for high speed is going to be the rate at high speed times the time it spends at high speed. So what is the rate at high speed? It was 40, right? So 40 centimeters at high speed. So 40 is the rate times the time. How much time did it spend traveling at high speed? 15 seconds. So 40 times 15. Okay, so what is 40 times 15? We know that 4 times 15 is 60, so you add the 0 at the back. So 40 times 15 is 600. Okay, you can do it long multiplication if you want, but you're going to end up with that answer, 640 times 15. And then how about a low speed? For low speed, what's the situation here? How far did it travel in low speed? So the distance in low speed is, we're going to use the same dirt formula. Distance is rate times time. So the rate at low speed is, let's see, high speed is 40 and then 15 centimeters per second. So the rate at low speed is 15. And how much time did it spend at low speed? 30 seconds. 30. Okay. So what is 15 times 30? You can multiply this by 3 and then just add the 0 at the back, right? So 15 times 3 is 45. If you add the 0 at the back, you end up with 450. So let's add it up. We're going to have 1050 centimeters. So our total distance is A. Okay, that's the correct answer, 1050 centimeters. All right, let's take a look at problem 107. It says Sarah can ride her bicycle 3 miles in 15 minutes. At this rate, how many miles can she ride her bicycle in 15 minutes? So we notice that we have the same rate situation here, so we can use proportions to solve it. It says at this rate. Okay, so let's see. How about we put the distance on the top and the time on the denominator. All right, so let's create a proportion here. So for the first ratio, she traveled 3 miles in 15 minutes. So 3 miles is the distance in 15 minutes. So 3 over 15 equals, now to set up the second ratio, we have to define what we're looking for. So it says how many miles can she travel in 50 minutes. So let x be the distance she travels in 15 minutes. By assigning a variable to your unknown, it's easy for you to create an equation, okay? So now we have 50 minutes and we have x miles. So which goes where? So since x is the miles, it goes on the distance portion, which is the numerator, and 50 is the time, so it goes in the denominator. All right, so we have this proportion here. Now, how do we solve for x? To simply solve for x, we'll multiply both sides by 50. We don't have to cross multiply here because the variable is already upstairs, so we don't need to do that. All right, on the right side, the 50s cancel out, and then we'll have x equals 50 times 3 is 150. 150 divided by 15, and we can clearly see that 150 divided by 15 is 10. Okay, so 15 goes here 1, 15 goes here 10 times. Our answer is option letter B. All right, let's take a look at question 108. It says Lisa typed a 1,000-word essay at an average rate of 20 words per minute. If she started typing at 6:20 p.m. And did not take any breaks, at what time did Lisa finish typing her essay? Okay, so we are going to set up a proportion here. Again, we have two quantities, words and minutes. Okay, words and minutes. How about we put words on top and minutes on the bottom of our proportion. Okay, words and minutes. All right. Now the first one we know is she does 20 words per minute. How do you represent that as a fraction? 20 words, 20 goes in the numerator. Per minute means 1 minute, so 20 over 1 equals. Now, this next ratio, she has 1,000 words. How many minutes did she spend typing 1,000 words? That's the question. Okay? I'll write that again. How many minutes did she spend typing 1,000 words? Well, we don't know. So let x be the number of minutes it takes to type 1,000 words. Okay? All right, so now in the denominator, we're going to put x because that's the number of minutes. All right? All right, now if we solve this equation for x, that will be our answer. Okay, so how do we do that? Now we're going to have to cross multiply here. Now, some of you might ask, oh, wait, why didn't we cross multiply? Why didn't we cross multiply in problem 107? If you look at problem 107, what you notice is that there's no variable downstairs. The variable's upstairs. In that case, there's no need to cross multiply. Here we have the variable downstairs, and that's not good. So if we cross multiply, the variable ends up upstairs. Okay. So if you cross multiply, you end up with 20x equals 1,000. All right. To get x isolated, we'll divide both sides by 20. Divide by 20. Divide by 20. And then you end up with x equals, you see you can divide by 10, that cancels the zeros, and then 2 goes into 150 times. So it takes Lisa 50 minutes to type 1,000 words if she types 20 words per minute. Okay, so she starts at 6:20. She starts at 6:20 p.m. And when does she end up when she adds another 50 minutes to this? So we're going to do some time calculations here. So the time is 6:20. If we add 50 minutes to 6:20, that's going to take us to 6:70. All right? So can you see 6:70 on the clock? 6:70 p.m. Absolutely not. This makes no sense. All right? After every 60 minutes, you have to wrap around. Okay? So we have to subtract 60 minutes from the 70 minutes. So if you subtract 60 minutes from there, what you're going to end up with is 10 minutes. So you're going to have 660 plus 10 minutes. All right? Let me write it in a way that's easy to understand. So we wanted to split this up 670 into 6 hours and 60 seconds plus 10 plus an additional 10 minutes. All right. So what is 660? 660 p.m. is the same thing as 7 o'clock because 60 minutes make a full hour. All right. So 667 o'clock. But wait a minute, we still have 10 minutes left. So if we add 10 minutes to 7 o'clock, that's going to take us to 7:10. Okay? So another way you can think of it is you're at 6:20. How many more minutes do you need to get to 7 o'clock? You need 40 minutes, right? And if you add 40 minutes, you have 10 minutes left. So you have 7 o'clock plus 10 minutes. So 7:10 p.m. is when she finishes. That's 50 minutes after 6 hours and 60 minutes. It's 60 minutes, 50 minutes after 6:20 p.m. All right, so there you have it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel so that I can get updates to other cool Cahsee review tutorials such as this. And please post a comment to let me know what you think about this presentation. Or click like if you liked it. And also feel free to share it in your respective social networking program. Thanks again for watching and have a wonderful day.